This one is door, figure 2.1a, door. We can represent door by just angle theta this way. This is inch. So we can represent the position of the door orientation also by just angle theta with inch this way. This one is the point x comma y in xy plane. So we require two coordinates x comma y. So number of degree of freedom 2. Now this one is coin in xy plane. See here. Suppose this one is the x-axis, this one is y-axis, and this one is coin. Consider 3 points A, B, and C. This one is xy plane, table surface. So first point A, we can put at any point on the xy plane. Suppose this one is here, this way. After fixing A, B must lie on the circle of radius DAB centered at A, this one. So for the representation of B, we require one angle theta, and then after fixing B, C must lie on the intersection of two circles having radius DAC and DBC centered at A and B, and there are two intersecting points for these two circles. One corresponds to heads, and if we flip here, keeping A and B fixed, see this way, then tails up. This one is heads up. So overall, we require three numbers for point A, xa, ya, for point B, one angle theta, which is on the circle having radius DAB centered at A. And after A and B fixed, C automatically fixed because C must lie on the intersection of two circles having radius DAC and DBC centered at A and centered at B. Now consider this coin. We want to find the position and orientation of the coin in 3D space. Now consider this one is x-axis, this one is y-axis, this one, and this one is z-axis. So here also for point A, we can fix at any location this way, suppose, and in 3D space there are three coordinates xa, ya, za. So for first point we can put at any location. So for first point, degree of freedom is are 3 xa, y, za. Then after fixing A, we have to fix B, which must lie on the spherical surface of radius DAB centered at A. So it's a spherical surface. So for fixing B, we require two parameters. It's a point on a surface of sphere, say longitude and latitude. So for point B, there are 2 degree of freedom, longitude, latitude. They are represented by angle. After fixing B, the third point C must lie on the intersection of two spheres having radius DAC centered at A and having radius DBC centered at B. And intersection of two spherical surface is a circle. So we know that on a circle we can fix a point by just angle theta, parametrizing angle theta. So if we consider coin in 3D space, there are we require minimum 6 coordinates for angle A, for point A, xa, y, za, and for point B, 2 parameters, longitude and latitude, and for point C, just parametrizing angle. So total number of 6 degree of freedom. If we consider the coin in 2D plane, we require 3 point A, B, and C in 2D plane. There are 3 points, so xa, y, xa, y, b, xa, y, c. So overall, at a first sight, 6 degree of freedom, but 3 conditions must be satisfied, constraints. DAB is fixed, DBC is also fixed, DAC is also fixed. There are 3 constraints. So 6 variable minus 3 constraints. So 3 overall, at last, number of degree of freedom of a coin in a plane is 3, and number of degree of coin in a 3D space are 6.